Hello, this video is for pre-algebra lesson 3-3 and hopefully lesson 3-4 as well. So I will try to move quickly to get both videos in. If you would turn to page 121 in your book, and we will be spending a lot of time looking at my notebook. So let's get started. We're going to learn first about multiplying rational numbers or numbers that can be written as fractions or decimals. Remember, the fractions cannot have a zero in the denominator, and the decimals must be terminating or repeating decimals in order to be rational numbers. But we're going to be looking first at multiplying fractions, which is really easy. You're going to find this to be an easy lesson, I think. I think the most complicated part of it will be working with the mixed numbers and the improper fractions and changing them back and forth. But let's get started. As you'll see, repeated addition is the same as multiplication. Let's look at what that means. 1/4 plus 1/4 plus 1/4 equals 3/4. But we can write that in a simpler way. We can write 3 times 1/4, which is the same as this problem up here. But then we need to know how to multiply fractions, or in this case, how to multiply a whole number in a fraction. Now, the first thing that I need you to remember and really cling on to forever is that every whole number is really that number over 1. Do you remember that? We've talked about that a number of times. Every whole number is really a fraction over 1. So now we have two fractions to multiply together, and that's where the easy part is. When we are multiplying fractions, we simply multiply straight across the top and straight across the bottom. This is different than addition and subtraction, where we have to have common denominators and we don't add or subtract the common denominators. Here we do the math with what's on top and the math with what's on the bottom. So you don't have to rewrite it. You could just look at it this way as 3 times 1 and 1 times 4. Or you can rewrite it like this and say 3 times 1 is 3, 1 times 4 is 4. And it is that simple. All right, let's do a few practice problems. We're looking at example 1A, and this is in your book. These problems are coming from your book, but I thought it would be easier for us to work out of my notebook today. So 1A, I have done all the way across. This is 6 times 2/3. Now remember, this 6 is a whole number, but every whole number is a fraction over 1. So we're going to say 6 times 2 and 1 times 3. We're going to multiply our numerators first and then our denominators. 6 times 2 is 12, 1 times 3 is 3. Now, please notice that this fraction is improper. So we need to switch it back to really be done. Remember that every fraction is also a division problem, with the division bar being the dividing sign. So we say 12 divided by 3, and that one's easy. That equals 4. All right, let's move on to 1B. -4 times 2 3/5. Do you remember what we talked about yesterday in class with mixed numbers? We cannot do easy math with mixed numbers. So that mixed number needs to follow our pattern for turning it into an irrational number to actually do the math. So first, let's recognize that our -4 is really a -4 over 1, because every whole number is a fraction over 1, times, and then here we're going to use our pattern where we say 2 times the bottom number plus the top number. So we're going to say 2 times 5 is 10 plus 3 is 13, and it's going to go over the 5 that's already in the denominator. So 2 3/5 is the same as 13/5. Now we're ready to do the math. Now it's just simple multiplication, except that I don't know what 13 times 4 is, so hold on. 52. Okay, so we have -4 times 13. Guys, do not overlook your negative signs. Be very careful and accurate with those. And 1 times 5 is 5. But this is an improper fraction, so we need to fix it. We're going to say how many times, well, first we're going to notice that there's only one negative sign, and so that our answer is going to be negative. Then we're going to say how many times will 5 go into 52? Remember, every fraction is a potential division problem. How many times will 5 go into 52? It will go 10 with 2 left over out of the 5. And there's the final answer. And for the denominator in my mixed number, I used the same denominator as my improper fraction. All right, let's look at another one. Here we're going to be remembering our rules about integers. Remember, when we're multiplying integers, a negative times a negative is a positive, or a positive times a positive is a positive. So anytime we multiply with same signs, it's always going to be positive. But if we have different signs, it's always going to be negative, like this one. So this one's going to be a positive answer. I don't have to put the positive sign, but I'm choosing to. And then simple multiplication. 1 times 3 is 3 across the top. 2 times 5 is 10 across the bottom. And this cannot be reduced. It is in its simplest form. Be sure if they ask you to put it in simplest form that you do that. But there is no common factor that goes into both of these to reduce it. All right, here we only have one negative sign, so we have a positive times a negative, which is a negative. And then we have multiplication across the top, which is 12 times 5, or 5 times 12, which is 60. And across the bottom, we also have 12 times 5, which is 60. What do you think negative 60 divided by 60 is? Well, of course, it's going to be negative, and 60 divided by 60 is simply 1. But now I want to show you a shortcut called canceling. If we had rewritten this problem as 5 times 12 over 12 times 5, and we had our negative sign out there, you would notice that we could cancel some things here, because a 12 divided by a 12 is a 1, and a 5 divided by a 5 is a 1. So this equals -1, just like that. Another way to look at it without having to rewrite the problem is to cancel without rewriting the problem, and to see that even when we're multiplying, we can cross cancel. Just as if this 12 had been on top of the fraction bar and this 12 had been underneath the same fraction bar, like when we rewrote it right here, we can simply say this 12 cancels with this 12, and this 5 cancels with this 5, and we are left with a -1, not a 0, because 12 divided by 12 is 1, and 5 divided by 5 is 1. So we are left with a -1 over 1, or just a simple -1. So you're going to find canceling to become very helpful to help you keep from using numbers that are too large. All right, let's look at example C. As you can see here, we have a mixed number. Cannot easily do math with that, so we're going to turn it into an improper fraction. 6 times 3 is 18, plus 2 is 20, and that is going to be 20 over the denominator that's there, which is 3, times 7 over 20. Now, we can use big numbers and multiply 20 times 7, which would be 140. And we would have, I'm going to write it under it because this isn't the way that I want you to do it, 140 over 60, because 3 times 20 is 60. As you can see, we're going to have a lot of reducing to do here. I can immediately tell that a 10 goes into both of these. So 140 divided by 10 is 14. 60 divided by 10 is 6. But I did not get the greatest common factor that first time around because I still need to reduce. Actually, you know what? We could have divided both of those by a 20. Let's try that. Let's see, 20 would go into 147 times, and 20 would go into 63 times. And there's our final answer. 7/3, and that's exactly what 14 over 6 would have reduced to if we had divided both of these by a 2. So our simplified answer is 7/3. Let's look and see how we could have gotten that more quickly. Notice that we had the same number on the top and on the bottom, and all we had to do was cancel them because they were basically going to cancel each other out anyway. And then we would have had a 1, which is what this is leaving. 1 times 7 is 7. And 3 times 1 is 3. Same answer, except for the canceling gave us a lot of math help. All right, let's look at the next one. This time we're going to be working with decimals. Let me flip my page. Okay, so here we're just simply going to apply our integer rules, or our negative and positive rules, and we're just going to do the math on this. So we're going to say 2.5 times 8. Before I do that, I'm going to look and see what I expect my sign to be. A negative times a negative is a positive. And 5 times 8 is 40. 16, that's 20. We have one decimal spot, so it's simply a positive 20. And that was super easy. Now let's try it with this one. Only one negative sign, so the answer is going to be negative. And I'm going to put the 4.6 on top. It represents a bigger, longer, well, actually you could have done either this way, but I like to put fuller numbers on top. 4.6 times 0.07, 7 times 6 is 42, 28, 32, 2, 3 decimal places, so it's 0.322, and it's negative. And there is our final answer. All right, I'm going to flip the page, and unfortunately, I can tell for sure that we are not going to get both lessons into this video. Disappointing. All right, here we are simply doing the expressions, solving for expressions like we've done in almost every lesson. So we're going to say negative 5½ times t, where t equals this. So we rewrite the problem, negative 5½ times whatever t is, which is negative 2/3. Well, we can't work with this mixed number, so we're going to need to rewrite it. And we're going to notice that this is a negative times a negative, so the answer is going to be a positive. But when I rewrite this, 5 times 2 plus 1 is 11/2 times 2/3. I've already dealt with my negatives, I already multiplied them and put the positive there, so now I'm just doing the numbers. 11 times 2 is 22, 2 times 3 is 6, but that cannot be my final answer because it is improper. So I'd like for you to go ahead and change it back. 6 goes into 22 3 times with 4 left over, 4, 6, 3 and 4, 6. And then that, as you notice, can be reduced. They're both even, so we can reduce them both by dividing by 2, so it's 3 2/3, or positive 3 2/3 is our final answer. All right, let's do the last one really quickly. Negative 5½ times whatever t is, and t is 8. All right, here we need to do some adjusting for both, but first I'm going to notice that my answer is going to be negative. Can't work with this, got to change it to an improper fraction, so that's going to be 5 times 2 is 10, plus 1 is 11/2 again, times, this is really a whole number, but it is also a fraction over 1. And we are going to have 88/2 as our answer. 2 goes into that 88, so we can simplify this by saying 88 divided by 2, and that's 44. And that is our final answer there, except we have to plug it in here. It's not actually our final answer. We have to put it with that negative sign. So negative 44. Another thing we could have done here, actually, I'm not going to go there. I was going to complicate it by showing you another shortcut that I think we're probably not ready for. All right, so that's the end of lesson 3-3, and I'm going to start another video for lesson 3-4.